All right, let's get everything going here. Thanks everyone again for joining. Today we're going to talk about accelerating machine learning with Snowflake. And so let's jump right in. Today, to go over the agenda, we'll start off with introductions. We'll introduce ourselves as well as who Snowflake is and phData. Then we'll start by talking about the life cycle of data science and some of the challenges that Kristen and I have seen in our experience. And then we'll kind of segue from that into talking about gathering and cleaning data and some of the challenges and best practices we've seen there. And then I will talk about scaling and maintaining your solutions and your organizations and kind of some best practices in that space. And then lastly, Kristen will talk about kickstarting your journey. So if you're new or maybe don't know where to start, some of the tooling options you have available to you. And then we'll recap and kick off some Q&A. With respect to Q&A, as we go through, feel free to drop questions in the Q&A section of the Zoom webinar there. I ask that you do that and not send them as a chat. Of course, if you send as a chat, we'll try and see it, catch it, but it's better, of course, if you put it in the Q&A. And then we'll answer those at the end. So let's jump right in. My name is Jordan Birdsell. I'm the General Manager of Machine Learning and Data Science here at phData. I've been here about 2 years, and prior to that, I worked out in the industry at State Farm, Stanley Black & Decker, and Geico. And Kristen, go ahead.
Yeah, hey. So I'm a director of data science and engineering at Snowflake. I've been at the company about 1.5 years now. My background started at Facebook roughly 6 or so years ago. I first started using Snowflake in 2016 when I started the data team for the Chan Zuckerberg Initiative, which is a philanthropic offshoot off of Facebook. And then I continued using Snowflake as a customer at a real estate tech firm called Open Door. So just about 1.5 years ago, I was able to join the Snowflake team officially. So now I get to do all the work on the product for other customers, like the teams that I've worked with in the past. So and with me is Mike, so I'll let him introduce himself as well.
Hi everyone. My name is Mike Lazinski. I'm the product marketing lead for Snowflake's data warehouse and data science workloads. I've been with Snowflake for roughly about 1.5 years. Prior to that, I led the product marketing team at real-time analytics company SignalFX. And prior to that, I was at Tableau for about 5 years in various product marketing roles.
Thanks, Mike. And Mike, if you want to introduce Snowflake, that'd be great.
Sure. So Snowflake is a cloud data platform. It helps organizations simplify how they store, manage, process, and access their data assets for every type of workload. So whether you're building a data engineering pipeline, forming a data lake or a data warehouse, or conducting data science, building data applications, or even sharing and exchanging data with partners and customers, you can do all that on Snowflake's cloud data platform. So we deliver the performance, the elastic scalability, and user concurrency required to run all of these workloads simultaneously, all using a single source of governed data without bottlenecks or resource contention. Next slide, please. So a little bit about Snowflake's architecture. Our architecture is actually quite unique, and it's designed specifically for the cloud. So whether you're choosing to run Snowflake on Google, Amazon, or Azure, you're going to have a consistent experience. And our architecture separates compute resources from storage resources. This gives our customers unlimited storage capacity and data that is centralized and consistent across all their workloads. Because of the way in which we store data, we're able to offer time travel for data, as well as secure data sharing. And our compute resources are called virtual warehouses. They're instantly elastic, so you can turn them on right when you need them and turn them off when you're done, only paying for what you use. Our virtual warehouses are offered in several sizes from extra small all the way up to 6XL to fit each workload exact requirements. To make things even easier, virtual warehouses scale linearly. Going up in size doubles performance, which also halves the amount of time a task will take. Because each virtual warehouse can be dedicated to a workload, team, or user, there's no resource contention. And finally, Snowflake is offered as a service. There's no ongoing maintenance, no vacuuming, no partitioning, no indexing. Updates are automatic with no downtime. And there's very little management. But we do offer robust enterprise capabilities for role-based access control, security, billing, and cross-region and cross-cloud replication. Our customers like to say that all you need to do is simply load your data and query it. Snowflake handles the rest. So how does Snowflake specifically support the data science workload? Next slide, please. It's commonly said that upwards of 80% of a data scientist's time is spent looking for and munging data, and a cloud platform removes a lot of that friction. By storing all structured and semi-structured data in one central place that's consistent for all users, anyone, as long as they have access, can query data using SQL, including natively for XML, JSON, Oracle, Parquet, and so on and so forth. Our dedicated virtual warehouses mean you're never competing for resources with data engineering or BI workloads. You can spin up powerful 1,000 core clusters to quickly conduct feature engineering and then turn them off when you're done. And you already have your favorite machine learning and deep learning libraries and frameworks. You can power them with data from Snowflake using our Spark connector. You can use Pandas data frames with Python, including support for Apache Arrow. You can use Kafka for streaming data and JDBC and ODBC drivers. If you prefer to use commercial tools, we have powerful integrations with DataRobot, DataIQ, Amazon SageMaker, H2O AI, Zeppel, and others. As a data platform, Snowflake makes it easy to use any ML tool you want. In fact, you can use them all simultaneously without needing to re-platform. And finally, because Snowflake is a cloud data platform, you can easily persist the data scored by your data science algorithms back into Snowflake, which makes it accessible by the rest of your business, your data analysts, marketers, executives, and product teams. That's it. Over to you, Jordan.
Thanks. Just a real quick introduction to phData. I don't want to spend a ton of time here, but we're a consultancy that's focused on machine learning, data engineering, and cloud data platforms. Specifically in the data science and ML space, we really pride ourselves on the MLOps standards and automation that we've created through working with our customers that has helped our customers to get ML models into production faster, more efficiently, and of course with less risk. We're about 160 people strong. That's both data and ML practitioners. Almost all of our customers are doing something in the data science space. And as a testament to that, we've helped our customers move over 5,000 models into production. And probably one of my prouder announcements as part of this is that a couple weeks ago, we were announced Snowflake's Emerging Partner of the Year for 2020. And so we're real excited about that. But without further ado, let's jump right into the meat and potatoes here and start talking about the ML lifecycle, the data science lifecycle. And the reason I wanted to start here was because I find it helps for folks to visualize kind of these different phases of work as we start talking about challenges and solutions, just so you can kind of put it in the right compartment. So for starters, we generally start a project in kind of this discovery phase. You may call it something else, but the goal here is to further define our problem, explore our data, gather that data, understand it, and so forth. Then our data scientist moves into kind of this training phase where we're experimenting, training the model, validating it, and all of that great stuff. After that, we need to do something with that model. So we generally move into this deployment phase, whether that's deploying up as an API served up in the cloud or as part of some batch process to integrate them with some business process. And then lastly, our monitoring phase, where we're actively trying to make sure that our model is still performing statistically and otherwise, but really critical phase here. Sometimes this gets overlooked, and I'll hit on some of the importance a little bit later. Just to real quick highlight some of the highlights I guess I'd seen from my career and challenges that I'd like to warn you about. First and foremost, kind of in that discovery phase of a project, that's where you're really trying to determine viability and, hey, can we get this thing off the ground? Can we prove some business value? almost 40% of projects that I've seen start in that discovery phase have failed to get off the ground because of some sort of data challenge. You heard Mike mention the 80% of data scientists spending their time on data challenges, and so this really highlights that, right? So if they're unable to get access to that data, if it's too hard to work with, if it's not clean, whatever, that can be a big problem. Next, I always like to make sure to suggest that you're getting some economies of scale over time. And so make sure to set up the next project for success. Don't work in isolation. The third thing, I mentioned this just a minute ago, don't skip model monitoring. If I like to say oftentimes that, if your model is not important enough to monitor, it's probably not important enough to deploy. And lastly, this is a misstep that I've made a couple of times in my career, where, early in the data science days, maybe this was just where I worked, but we all thought we were the smartest folks in town and that we knew what was best. In reality, though, there was a lot of best practices and things that we could have adopted from other IT sectors, like DevOps and so forth, that really would have helped us. And so you've probably heard the term MLOps surface in the last year or two, and that's really what that's focused on. And we'll talk a little bit about that more later. I'm going to turn it over to Kristen, and she can talk a little bit about her experience and go from there.
Yeah, so when Jordan and I were talking about this, I think we both had slightly different initial responses to like what we found, what we think of when we thought about what was challenging about our jobs and work. And I totally agree with everything Jordan said, but kind of for me, the things that first came to mind were kind of these three pieces that you really need to have in place to get data moving forward at a company. So about trust, adoption, and driving action and strategy. So what I often tell my stakeholders as well as my team is that data doesn't actually do anything without trust. Like trust is this main thing that it has. So I focus a lot of our efforts on creating sources of truth and a coherent data model across the company, so that folks are able to easily reason about kind of the numbers and models and outputs that they're looking at. Provide your stakeholders data quality assurances and proactive communication. And we'll talk about this a little bit in the next section, so I won't go too deeply here. Pushing for adoption. This is about data visibility, making sure you could hide all of your tools in notebooks on your laptop, all of your results here, there, and have a pull model where someone has to ask you for stuff. It's much better if you can set it up so your business stakeholders and anyone who you want to leverage your data, if it's other data scientists at the company, is accessible and interpretable. And this is also get into the next section a little bit more. And then I always tell people that and my team, like, data's first job is to make sure that your business's roadmap is successful, that it's doing its very best at what it can do when you are driving action and strategy. So making sure you keep those tight relationships with the business stakeholders. And even if you're doing really complicated machine learning, making sure it's interpretable and understandable from the folks you're working closely with, so you can actually get it to implement on the ground change. So next slide. So kind of taken together, I think these the things Jordan talked about and I talked about are kind of speak to different facets of the same sort of experience. You have spent all this time gathering and cleaning data. You spend a lot of time doing it so the data scientists can do a job, but also so that you can build this trust and everything in your data that you're exposing inside the company. And it's one thing to do it with one or two people or a small team, but as you start to scale, your business grows, doing that in a coordinated way is super hard. It's a totally different tack than you would take in the first, 1 or 2 years as you're just getting started. So in the next slide, in the next slide, we're just going to go through some of the steps about gathering and cleaning data and some of the challenges we see. Next slide. And then also try to address briefly in these slides, and we can get more into in the Q&A if folks have questions. We just want to touch on a bunch of things, but just touch on some challenges and some best practices through this section. So the 4 kind of overarching topics: finding and accessing data, data quality, governance, and data cataloging. So I'll cover the first 2, and then I'll pass it over to Jordan. Next slide. So challenges of finding and accessing data, right? it's often or not infrequently the case that you may have data siloed, and it can be siloed by data infrastructure. You might have some on-prem and some cloud, but you need to be able to know what data you have to be able to do your job as a data scientist. So even if they have, and then even if you have it sort of cleaned and in each relative silo, it still can be hard for data scientists to understand what's going on, put it together, figure out how it relates to the problem they're trying to solve. And then the second sort of layer of finding and accessing data is like, even if you find it, know what's in there, you've explored it a little bit. If you have a lot of people running queries concurrently on a restrictive data warehousing system, you may not have the compute resources to actually get your results back. So next slide. So the way we think about this at Snowflake, and I also thought about it similarly at other companies as well. But you want to have that flexibility to combine whether your data is in a data lake or kind of a more structured data warehouse. So data lake, kind of raw data where you're just transforming it on the fly or on demand, versus a data warehouse where you might think of like, you load, transform, and then use the data for a final output, or some mix of the two. And this happens often when you're fueling both BI and machine learning from the same place. Being able to do any version of that and keeping everything accessible in one system is something that Snowflake does really well, but that's something that I think I would suggest really thinking about how can you enable that in your infrastructure to empower your data scientists to access what they need. There's another thing about coding languages. SQL is really universal and easy to use, and something for us at Snowflake, we're optimized on SQL, right? So we're going to run SQL as efficiently as possible. It's part of the core product. When you start using Spark, great for some things, but you have to start introducing new skill sets and levels of expertise of whether you're going to use PySpark or SQL and Spark, and how those jobs will run so that you're making the most of the system. And then it's an additional system to manage instead of having one SQL store. Choices, but definitely things you have to be aware of. And then there are a couple other things that we think about at Snowflake that I think add a lot of value to the overall finding and accessing data process. So at Snowflake, we have a data exchange and marketplace. One of my teams does account scoring and account enrichment. It's a depth first search problem and a matching problem and all this stuff. So we get data shares from our customers who are also, vendors to us in terms of account data, and we're able to get the most up-to-date, pre-transformed data from them via data share. Supports semi-structured, structured data, so you have a lot of flexibility there if you're importing a lot of JSON blobs. We support streaming via Kafka, and as well as our proprietary tool Snowpipe. I won't get into that too much here unless folks have questions later. And then this idea of zero copy cloning, so less, being able to use the same data, same source for testing out models and doing destructive testing without increasing storage costs and usage and creating multiple sources of truth. So, so this is a really big area for us, and I spend a lot of time thinking about it, particularly at the company I'm at now. So next slide. For data quality, so once you get all your data in the same place, you want to make sure it's good. The worst thing that happens, and it's happened to every team I've ever been on in my career, is that your business partner is the first person to find out there's something wrong. This is terrible. It's a terrible outcome. Like they don't trust that you've done your job well. You haven't assured them that you're going to take good care of the results that you're handing them, and they're going to be high quality. And then you start spinning the wheels, all hands on deck, having your data scientists go and figure out what happened, why did it happen, how do we prevent it from happening in the future, and you might be in a place where you're patching the system and instead of thinking a little more holistically about it. And perhaps like a more corrosive case is like when the bad data gets into your models and stays there for a while and goes undiscovered for a longer period of time. So next slide. So we kind of start from the same place when you think about how do we ensure best practices around this. The same place with like finding and accessing data is that we think about the data ecosystem holistically. So you pull all of the data in one place. You have some steps and standardized tooling for cleaning that data. You have some standardized steps that for creating your coherent data model and feature store, which might be a little, and I know Jordan's going to talk about feature stores a little bit later, but a specific case of data modeling. And then your ML algorithms that will run off of this and maybe off some other data in a data lake. But when you have it all in one place, you can think about standardizing all of these things and doing data checks on your full set of data that are relevant to the stage of processing that you're at. So when it comes in, is the data the right size and shape? Are we going to run these pipelines on the right set of data? So data that was collected on the same day, for example, to prevent race conditions. So are the dependencies ready? Are there unexpected changes in the data? Is there drift or anomalies? Anything like that that we don't want to go into a model? And then once you get to the modeling part, you want to test it and evaluate, like, does this make sense? Is this a reasonable outcome before I just push it into production? So this is very high level, happy to get into more in Q&A. But how I think about bringing your data together and thinking about quality assurances on its path to production. And I'll hand it off to Jordan now.
Sorry, still muted there. Thanks, Kristen. The next topic I wanted to cover is data governance, and specifically governance with the data science lens, right? We don't have enough time to dive in and talk about exactly how to establish your governance practices and so forth. But we do have time to share a little bit of lessons learned from our experience. And so the first point, obviously, is no process is a bad thing, right? Ultimately, what that leads to is free access or no access for anyone. And I have actually run into this. Hopefully, most of you aren't in that situation, but if you are, let's create a process for requesting access to data and so forth. As part of that process that we're create, we want to make sure we identify appropriate data owners. And by appropriate, what I mean is, our recommendation is that data owners be in the business units. And what this does is it gives the business units responsibility over their data, which they should have, and it aligns data ownership with data knowledge. I guess the inverse of that, if you didn't go this route, would be that IT counterparts own business data, and that can lead to some confusion with users of the data and misalignment with business practices. So generally, we recommend that go to the business units. The next point I'd make is data owners make sure they understand how their data is being used. And the reason I bring this up, I'm reminded of a circumstance when I worked at State Farm where we first assigned data owners out to the business areas. But data science was a very new idea at the time. This was almost a decade ago. And what would happen is we'd go and request all this data in typical data science fashion. But these data owners were still so accustomed to business intelligence as what they identified with as analytics. And so in business intelligence, when you're creating reports and so forth, you're going to request very specific fields, right? I need this, this, and this from that table, and maybe these 5 things from that table. Whereas in data science, generally you're going to request everything in that business owner's domain. Or close to it. And so that can be pretty alarming as a person having to be responsible for that if they're not familiar with what data science is all about. And so to solve for that, I'd recommend connecting your business units back with the data science teams, allow them to collaborate a little more closely to help solve for that. The last point I wanted to make is, and maybe this will resonate with a lot of you, data governance processes naturally become very cumbersome over time. Any process does. And of course, we recommend that you constantly stay on top of that and evaluate. If you recall, I mentioned a lot of projects fail to get off the ground if they can't get to data quick enough. And in fact, I'm reminded of circumstances in the past where it took so long to request access to data, months to request that access, that we actually didn't even bother with projects if it just felt like it wasn't a good use of time. And so make sure you're constantly staying on top of that. That's enough of governance, though. Let's jump into data cataloging as the next topic that I'd like to address. The first and foremost point here is obviously, data scientists without a data catalog don't know what data exists. And even if they do find the data, they don't know how to make sense of it, and it becomes this really trial and error sort of process that you see on the right here, where they're having to go back to these, domain experts with all this tribal knowledge and kind of rinse and repeat and do it again and do it again. And it's really not pretty. And so what that leads to is a lot of waste and rework, and we want to avoid that. And so obviously the answer to that is introduce a data catalog. But what I'd like to offer you is a little bit more than that from a best practices standpoint. One thing I've seen in the data cataloging space where things have gone wrong is when data pipelines aren't integrated in with the catalog, meaning they're not updating the catalog on a regular basis or on an automated basis. And what happens, it kind of gets to Kristen's point of trust, is if your data catalog's not being kept up to date, then trust is no longer there. And so if trust is not there, then your data catalog is absolutely useless. And so it's really critical. In fact, you see on the right there, we have this sort of high-level architecture diagram where we're demonstrating how, we, again, at a high level, we would integrate our pipelines into the data catalog. Streamliner, that tool in the middle there, by the way, is a tool phData built that helps automate the creation of data pipelines using both Snowpipe and kind of connecting out to your relational stores. And we've built a component of that to integrate automatically into your data catalog. The next point I wanted to make is kind of highlighting some key things that data scientists look for in a data catalog. Most of these are obvious, so I'm not really going to touch on those. The two that I would address is data relationships, so entity relationship diagrams, whether they're physical, logical, etc. Being able to understand how to join tables together is really valuable, and so making that available in some capacity to data scientists is valuable. And then the next point I wanted to make is profiling information. I really wanted to emphasize on this. It's not something I frequently see in a data catalog, but if you recall back to what I mentioned about the data discovery phase of a project, a lot of what a data scientist is doing in that phase, once they've gathered the data, is going in and trying to essentially profile the data. They're running all these queries they keep up in their back pocket, essentially, to try and get a deeper understanding of what's in that data set. And so what I found, and an experience I had at Stanley Black & Decker, we integrated data profiling jobs that we ran on a regular basis. We integrated that into the data catalog, and it really saved data scientists a lot of time. So that's it for kind of the data gathering and cleansing sort of part of the discussion. I wanted to move right on into scaling and maintaining. And in particular, the two areas I'd like to discuss are feature stores and MLOps. And so these might be new terms to you, maybe they're not, or maybe you're just a little fuzzy. And so let's recap on what they are. So for feature stores, our primary intent with a feature store, the problem we're mainly trying to solve is as I mentioned earlier, setting up the next project for success. And the way we do that is by reducing the amount of rework that a data scientist is having to do, or a data engineer, in that data prep and kind of feature engineering space. So let's illustrate this by looking at the diagram here on the right. So we have our data sources there at the bottom. We have a data scientist that comes in and starts training model A. They've created feature A going after this SQL table here at the bottom. Well, now we have data scientist 2 that's coming in, and he's training model B. Well, he also needs feature A, B, and C. And if you notice here, feature A in red, he had to actually recreate feature A using his own code. Maybe he wasn't aware of what data scientist A had done, or what have you. Same thing with model C. Different data scientist comes in, needs different features. They had to do some rework. And as you can imagine, as you add more data scientists, more projects, this becomes really inefficient really fast. The second point that's still valuable and I really want to drive here is this inconsistency between features used to train and features used to serve or to deploy. And so let's look at model C here. Our data scientists created features C, E, D, and F in Jupyter. And they ultimately go to deploy. They pass that over the fence to an engineer who then has to recreate C, E, D, and F in some sort of Java process or Scala or something like that. And most likely they're doing some testing and validating that everything matches. but it's generally not a good practice to have those separate, right? Now we have our deployed model and our training scripts running on completely different calculations. The other 2 points I guess I'd like to make on feature stores is it can help with tracking and improving model accuracy, and also with improving some of the lineage tracking of these features, right? So if you're not doing stuff in Jupyter and kind of putting some more central control around that, you can really beef up your lineage. But I'll talk on those in just a minute. So let's look at this scenario again. And this time look at it with a feature store, right? So again, data scientist 1 is coming in, training model A, and when they create feature A, they create it in the feature store. Data scientist 2 comes along, they have to create features B and C, but they don't have to create feature A. Same story with model C, right? And then by the time we get to deploying model C, we don't have to create anything. The features are already there. So the engineer in this case really only has to create the deploy code that accesses those features. So it's a really efficient process. So that's great, right? So what are some best practices that we can recommend as you build out a system like this, and some things to consider? First and foremost, don't forget your data catalog. We already talked about the importance of this, but I really wanted to drive that home. It's probably more important in the feature store than it is in other places. So continue to use that. Next, let's remember, we talked about using, these features and how our deployed Model C also didn't have to re-implement the features that we created for training, right? Well, in a traditional data system where we have to separate compute and storage, that can be problematic, right? Maybe I created them for training, but now I actually have to replicate that logic up into some production environment or something like that, as well as replicate the data. And that's not very efficient, right? And so we're losing some of the benefit of our feature store. Well, if we use Snowflake as our feature store, there's a couple of features that they add that ultimately enable us to separate that storage and compute and to make this more efficient. And the first part of that is this idea of virtual warehouses. So it was mentioned earlier, but essentially we can separate, our training job and our deploy job can both have two different compute clusters that are accessing the data. And then through zero copy cloning, that makes it so we don't have to copy that data around. And so now we have multiple clusters, compute clusters that are independent of one another, serving different needs, accessing the same features without ever having to copy the data. And so Snowflake makes that really simple. The next part, I talked about the ability to improve on model monitoring and kind of traceability. And so one of the next things I would recommend is keep some additional metadata inside your feature store that tracks this lineage. So we see all these different pipes coming in. If we look at feature A, for example, we know just looking at this diagram that it's being used for model A and model B. But in a real world setting where we have thousands of models and tens of thousands of features, or even more, that becomes really complicated. And so, adding in some metadata that allows us to track how those features trace back to ultimately the model is really valuable and can allow us to even do some downstream impact. So, for example, if data scientist 1 is updating model A, and as a result, they need to update feature A, and they pass that off to the data engineer who's going to update the feature store. Well, the data engineer would know that model B is also going to be impacted by this. And so it gives us that visibility across those projects. That's really valuable. So that's it for feature stores. Let's talk about MLOps now. I got this little diagram here on the right, and if you've been in the ML space longer than 6 months, this probably really resonates with you. Essentially what we're depicting here is data scientists going out, grabbing data, bringing it to the laptop, then building some Jupyter notebook that does all their cleansing, pre-processing, and so forth. And then they need to deploy it, so they pass it over the wall to an engineer who doesn't know what it is or what to do with it. This is a tale as old as time when it comes to data science. It was a problem, almost a decade ago when I started in this space, and it's still a problem today. But over the last year or two, as I mentioned, this MLOps topic has become more and more prevalent as the industry has been trying to solve for this deployment problem. But let's touch on some of the reasons why specifically this has been problematic. And so first and foremost, models and code are generally not being properly versioned. I don't mean to suggest that no data scientist has ever versioned a model or their code, but more often than not, when we, at least when I get involved in projects, we're finding that that's not the case, right? Next, from a governance and kind of oversight perspective, a lot of times these training runs or experiments, they're not being tracked and there's no lineage. So, you know, if a governance body comes in and says, hey, how did you come up with this? Can you reproduce this result? The answer is no in a lot of cases, or at least it requires a lot of work. Next, we see a lot of inconsistency across project architectures. And so, you know, Model A and Model B in the last example, one might be Python, one might be R. Not that there's any problem with that. And maybe we package them totally different and so forth. And so not a lot of consistency. And then lastly, I've mentioned this again and again, but neglect of model monitoring and retraining. And this is a really key item. So, you know, I guess let's start by, you know, looking at maybe kind of a core example of ML ops, and let's look at an ML DevOps pipeline specifically for production. So I'm not going to touch on kind of the research and exploratory side here. That's a slightly different topic. Here, what we want to look at is a DevOps pipeline for something in prod. And so, as you might imagine, we start with data, pretty straightforward. Next, you know, we have a data engineer who's engaging with that data, doing something with the data, and then ultimately storing in our feature store. And we're using, you know, some kind of version control in our data ops CI/CD platform to manage how we're versioning those features and so forth. Next, we introduce our data scientist who starts developing their model. Again, they're using version control. This is ideal world. And then they move on to train it at scale. So again, this is different from exploratory, so don't be distracted by that. This is more a production kind of training job. And then they use the MLOps CI/CD platform, which is most likely the same actual platform as the DataOps CI/CD platform. But they use that platform to then trigger their model training and validation jobs. So by checking in their code, there's, you know, maybe a DevOps pipeline in that Jenkins install or whatever it is that gets triggered and kicks off some training job in SageMaker or MLflow or something like that. And then lastly, we go to deploy, right? And so the same story there. We're going to use our MLOps CI/CD platform to then trigger deployment and kind of our monitoring framework, again, up in the cloud, whether that's SageMaker, et cetera. And so this is, again, this is a very basic overview of what an MLOps pipeline might look like. But I think it sets the tone to dive a little bit deeper. So let's jump into maybe some tips that we'd recommend to improve this. So as you look to build out your pipelines, you know, what can you do? First and foremost, you know, track your model training runs or your experiments. Make sure you're tracking that, right? You want to make sure to look at things like versioning or tracking your hyperparameters, your code, your data, and so forth. All the things that you need to be able to reproduce that training run should be tracked in some sort of system. MLflow offers a good solution here, SageMaker. There might be a couple others, but you know, those are some strong choices that I've worked with personally. And then, you know, kind of as an extension of that point, add in some sort of model registry that allows you to more holistically manage the life cycle of your model. So without something like that, ultimately your model is just a bunch of loose parts kind of scattered around, right? I have this pickle file here. I've got maybe this code here that will execute that pickle file. And it's just kind of these scattered pieces. But with something like a model registry, I can then, you know, better version those things and kind of track their progression through various environments. And again, something that a tool like MLflow has with ML, their model registry. Next, I think I mentioned this earlier, but maybe not. You know, I would suggest that you know, all your predictions that you're making on your model that's being served in production, that you log those inputs and outputs back into your feature store. Now, at this point, your feature store is essentially just becoming, you know, some data science layer of your data lake, which is effectively what it is anyway. But but yeah, having that that log back feature enables you to more effectively monitor your models as well as to retrain them when the time comes around. And then lastly, or I'm sorry, not lastly, the next point I wanted to make is, in the MLOps CI/CD platform, one of the things you might have been thinking about here, or maybe you assume this was already the case, is by having those DevOps pipelines set up, you can enable automatic retraining. So maybe I have 100 different experiments for this model that I'd really like to see run once a day, or maybe every time the data changes. And because I've got this ML platform in place now, I can enable that to happen automatically. And the benefit there is, of course, better visibility, but also it's a strong addition to your monitoring strategy. Meaning, if I'm training 100 different experiments every night, and all of a sudden, 10 of them or even one of them is strongly outperforming my model in production, then it's probably time to update the model. So valid suggestion there. The other point that you're probably thinking of as we mentioned that is, hey, then I could probably automatically trigger deployments as well, based on that detail. And that's certainly true. Most industries, however, generally are not okay with that at this point. They usually want some sort of human intervention in between training and deployment. But if you're in an industry that allows that, then by all means, run ahead. The last point that I wanted to mention is less about the production side and more about getting a data scientist off the ground. And so one of the problems that we saw at our customers was that, especially in the cloud, is when data scientists, especially citizen data scientists, would start on a project, they had to go out and they had to make sure that all the right S3 buckets were created. They had all these IAM roles and so forth, and all these different artifacts they had to have created in the cloud. And it became very challenging, and oftentimes steps would be missed and we'd have security flaws and so forth. And so this is a big problem in just getting projects off the ground. And so what we recommend here is, using some sort of cloud automation to create project templates. phData, as an example, we've built a tool around this to help data scientists get projects off the ground, and it's got various different project artifact types. So maybe it's a computer vision project or something to that effect. And they can just go in through a CLI and it'll spin up all the resources they need in their cloud environment. And so, again, just another thing we'd recommend, especially in the cloud space. So that wraps up MLOps. I'm going to kick it back to Kristen, and she's going to talk about how to kickstart your journey if you're new or maybe business analyst, and the rest of this is a little bit less relevant, but I'll let her chat about that.
Yeah, totally. So next slide. Cool. Yeah, so something that I really like to do when I'm trying to figure out what the right work to do is and what's the right way to do it is to really be specific about the problem and what you're trying to solve and how you want to solve it. This comes up in all sorts of aspects of data. You can imagine, 5 or so years ago, no one knew what a data scientist really did. And now we know there are several flavors of data science, and you really have to name what those things are, because data science isn't just data science, and modeling is also not one thing. So here kind of talk about 2 different flavors and some of the open source tools that will support those workflows. So on the left side of the screen, statistical algorithms. This is your t-tests, your linear logistic regressions, probabilistic evaluations. So this is good for kind of your structured, semi-structured data. You're able to evaluate your models with smaller volumes of data. This is a sample size, central limit theorem kind of problem, and also really well understood. There's a lot of great resources and blogs on the web about when to use what kind of test or what kind of statistical analyses to work with your problem set or problem area. Neural networks and deep learning. This type of modeling really thrives with large amounts of data. Discovering things that a human, throwing computational power at problems and questions with large volumes of data that a human doesn't have enough hours in a lifetime to process and fully understand. without computers. So the performance also increases with the size of the training data. But the way they want to add here is that because they are newer and they are extremely complex, interpreting them and understanding them afterward is really where a lot of work goes in. So you want to know why you got the result that you got. You're going to spend more time on these sort of, kind of understanding what happened in the algorithm once you kind of set it up to be able to use and relate your results to your business stakeholders. Next slide. And another decision point is like, how much do you want to do custom and how much needs to be custom and what can you use third-party tools for? Some folks I've worked with talk a lot about, you buy sort of the general stuff and you build proprietary. So you buy commodity, build proprietary. For me, someone like me, I really love doing custom everything. I want to build it myself. I think it's super interesting to do, but it's not always the right answer for the business. So you sit back and you think, who needs to be developing algorithms? Who needs access to them? What problem are we trying to solve? Do we need to do something custom? Are there existing tools? So there's a whole ecosystem of tools that you can use. Some here are open source. Some are businesses themselves, but I think there's a whole suite to evaluate. And I think to speak to what Jordan said earlier about looking at other areas of expertise, how do you do things well, and understanding how other people work will can inform some of these decisions about do you do custom or do you do sort of third party. I'm happy to chat more about that in the Q&A as well. Cool, Jordan.
Yeah, thanks, Kristen. So let's recap. So what did we hope you walked away with here? First, that building a data platform for data science is totally within reach, and Snowflake certainly makes that easier. I hope you got some key tips on how to build your data platform, specifically to support data science and machine learning. And lastly, that feature stores and MLOps are really key to help you scale your team as you grow. I don't want you walking away here with nothing. And so, as a next step here, we're phData. We're really happy to dive deeper on any or all of these topics covered here today, or even to dive into some use cases or anything else that you'd like to talk about. And we can do that through a no-cost workshop. Generally, what you'd come away from with something like that is with some vision and maybe some next steps for your platform or use case. And we can tailor these to both technical roles or leaders or both. And oftentimes we've seen that range from anywhere from 1 to 3 hours. If that's interesting to you, keep an eye out for the survey that'll come out here later today. And in that email, there will be some guidance on how to engage us. But aside from that, about the survey, please fill that out. We'd love your feedback. And with that, let's kick it over to the Q&A. And it looks like we have a couple in the Q&A section. There's a few that came to me through the chat. So let's go with the Q&A first. Let's see, how does Snowflake enable feature stores? So just to kind of recap on some of that is through virtual warehousing and through virtual warehousing and through zero copy cloning that really simplifies that need to separate storage and compute on kind of the feature store side, meaning now with that I can serve features up to multiple training jobs, also across training and into production, and all of those can access the same copy of the data with multiple compute clusters. And so I believe that question came in before we addressed that, but hopefully that helps. Let me see what the next question is. Are tools that aim to solve
Jordan, can I add a couple things onto that as well?
Yeah, go for it.
Yeah, so we also have available external functions where you can call external tables to fetch features if you have them stored somewhere else. And as you mentioned, you can just push down results into Snowflake. Also, some of the evaluations of stuff, if you wanted to calculate variance or standard deviation differences between examples on a search tree or whatever. These are things that you can do inside Snowflake themselves. We have functions that do that. So we have a couple options that are building more to make the system extensible for things like feature stores.
Thanks, Kristen. The other question was, are tools that aim to solve data transformation, governance, and dataset versioning like DBT and DVC respectively welcome additions to the product landscape, or does Snowflake see these as things that will be built into the online data platform down the road? And so I want to defer that to Kristen or Mike, since that seems to be directed at Snowflake, kind of more of a product roadmap.
Yeah, so I want to say first, we use DBT, and we also use Airflow. I'm not familiar with DVC, to be honest, but I think this is a thing. So, and you may know that Snowflake has tools like streams and tasks, which enable kind of a lightweight data pipelining mechanism native to Snowflake. It's different from DBT and it's different from Airflow. So I would say evaluate kind of where you're at and what you want to do. These are all great tools, and they are powerful in different ways and also for different skill sets. So I would say, if your company is light on data engineering, DBT and streams and tasks, really nice and accessible. If you have kind of a data infrastructure, data eng type of team, Airflow becomes really, really powerful. So I think we kind of are still in this space where we want to offer something available natively, but there is a suite of tools out there that we use ourselves that are really good in this space.
Thanks, Kristen. Let's see, another question that came in: how does Model B know that a feature developed in Model A is developed in Model A? How can different models collaborate? Is it a built-in feature of a feature store, and does it need to be configured? And so let me see if I can't kind of piece this apart. So in our example, if you recall, I mentioned that one of the best practices there is, of course, to continue to use the data catalog. And so by having a data catalog attached to your feature store, that's how data scientists developing Model B would know that feature A was created by Model A. Now, if they're both in development, that's obviously a little bit less obvious, and maybe the teams just work together in that sense. But here we were assuming Model A had already kind of entered that feature into the feature store. And so that kind of highlights how they collaborate. Of course, there's other ways that data scientists can collaborate, but in a feature store space, it's by making that data available for others to use and to catalog that, so people know it's there. It's a feature. To answer the question of, is it a built-in feature of a feature store? I wouldn't say it's built in. Feature stores, by the way, are just kind of a concept. I guess there's a couple tools out there that are explicitly feature store solutions, but these are mostly just concepts. And so, I wouldn't say it's a built-in feature, the cataloging piece. So thanks for that question. Let me pull up these ones I had in the chat. Just a second. Let's see. One of the questions I got was, what tools do you recommend for data cataloging? And so I can take a stab at that and then maybe turn it over to Kristen or Mike to answer from Snowflake's perspective. I've seen a number of things work. Elation obviously is your big one. Calibra is another. Both of those are great solutions. I've also personally had success with rolling my own. And so I mentioned the Stanley Black & Decker example earlier. And at Stanley Black & Decker, when I was there, we built our own data cataloging system using Elasticsearch and just hooked our pipelines into Elasticsearch and our data profiling jobs and so forth. And so that's kind of my experience on that. But Kristen or Mike, I don't know if you have anything to add from your perspective.
And we have some of the ones you mentioned, Elation, Calibra. There's also data.world are all in our partner network, so they work really well with Snowflake. I have the same experience as you, Jordan. I've also written my own. And for the person who asked about DBT, I don't know if you've used DBT, but they have a really nice data documentation, data docs sort of feature there where you can create YAMLs. YAMLs give you a key value store essentially that you can read off of to build your own data catalog. So I think that this is like a where are you at? And I think the best possible thing you can do for your data is just make sure you're storing the metadata, like creating metadata, table owners, table sizes, what's in it, the definitions. Just start documenting, and then wherever you decide to go, whether it's build your own or purchase a tool, you'll be ready to load your data in and stay organized.
Thanks. The other question I had in chat was, you mentioned a MLOps CI/CD platform. What does that look like? What tools are included? So in my experience, a CI/CD platform for MLOps is really no different than a traditional CI/CD platform. So we're still talking tools like Jenkins or Circle CI. As an organization, who does a lot of consulting, we've frequently found ourselves using Jenkins kind of as our tool of choice just because of how robust it is. However, Circle CI has kind of a nice cloud native feel to it, and so sometimes it's easier to get off the ground with Circle CI, but maybe a little less robust than Jenkins. But yeah, so generally that's what that looks like. But then, for cloud automation and things like that, where that comes into play, it depends on, of course, your cloud provider, but you might use something like CloudFormation or something like that. I think we are running out of time here. So again, we'll be sure to send out the survey email, so you'll get that. And for those of you who aren't on here, which is neither here nor there, but we'll be sending out the recording to those folks. And so if you're listening to this then, I hope you're enjoying it. And thanks everyone for joining, and glad you were all able to make it.